minuscule fleck, barely a pinprick, buried in decades-old telescope images from two sky surveys taken 23 years apart. And yet, this dim little dot could represent one of the most significant discoveries of our era. Because if scientists are right, it may be the long-hypothesized Planet 9. This object is thought to be larger than Earth, but slightly smaller than Neptune, placing it squarely between rocky worlds and icy giants. Its path around the Sun is nothing like the neat, flat orbits of the planets we know. Instead, it follows an extreme trajectory, stretching out to distances nearly 20 times farther than Neptune's orbit. So why do astronomers believe Planet 9 might exist at all? The story begins in 1781, when an English astronomer named William Herschel was methodically sweeping the sky with a telescope he built himself. He was hunting for comets, but what he found didn't behave like one. As observations piled up, astronomers realized this object was circling the Sun in a slow, predictable way, just like a planet. They named it Uranus. But there was a problem. Uranus wasn't moving exactly as Newton's laws predicted. Its orbit showed subtle irregularities, tiny deviations, but enough to spark curiosity. Enter Urbain Le Verrier, a French mathematician armed with nothing more than equations and patience. He proposed that an unseen planet must be tugging on Uranus, disturbing its motion. Using mathematics alone, he calculated where this hidden world should be. When astronomers aimed their telescopes at that precise location, they found Neptune, exactly where the math said it would be. Now jump ahead to 2016. Two Caltech scientists, Mike Brown and Brown Batygin, were studying the orbits of several distant objects in the Kuiper Belt when something odd stood out. These paths weren't scattered at random. They were grouped together, angled the same way, as if an unseen heavyweight were quietly pulling the strings. As Brown and Batygin dug deeper into the data, it pointed to a startling explanation. The only thing capable of shaping those strange, aligned orbits would be a hidden planet, one 5 to 10 times the mass of Earth, lurking far beyond Pluto. So distant, in fact, that it might be nearly impossible to spot with ordinary visible light. They dubbed it Planet 9. And since then, astronomers have been hunting for it, following faint clues at the very edge of the solar system. Because the farther an object is, the dimmer it becomes, especially if it reflects very little sunlight. That's why the search shifted to infrared. Scientists combed through two all-sky infrared surveys, one conducted by the IRAS satellite in 1983, and another carried out by Japan's Akari mission between 2006 and 2011. Which brings us to the most recent breakthrough. A team led by astronomers at National Tsinghua University in Taiwan took a clever approach. They searched for objects that appeared in both surveys, but not in the same position. The logic was simple. If something shifted slightly over those decades, it might be orbiting the Sun, just incredibly slowly. This isn't like tracking a comet streaking across the sky. Planet 9, if it exists, would crawl along at roughly 3 arc minutes per year. That's almost nothing. For comparison, the full moon spans about 1,800 arc minutes across the sky. So how do you even notice movement that subtle? That's where parallax comes into play. Think about holding your finger in front of your face, closing one eye, then switching to the other. Your finger appears to jump sideways. That's parallax. In astronomy, Earth's orbit around the Sun creates the same effect. By observing the sky from different positions along Earth's path, astronomers can detect tiny shifts in where distant objects appear. Over enough time, those shifts reveal whether something is moving and how far away it truly is. Based on this, the team searched for objects that showed up in the same place at the same time every year, canceling out parallax. Then, they narrowed it down further by checking if those objects were slowly drifting over time. And eventually, they found one. A faint dot in the IRA's data from 1983. And another dot 47 arc minutes away in the Akari data from 2006. Could it be the same object? Could it be Planet 9? Possibly. Because based on its brightness in the infrared data, it would have to be more massive than Neptune. Well, if we know roughly where it was in 2006, we can try to spot it again with powerful optical telescopes. But here's the problem. In the years since Akari spotted it, this object would have moved, and we don't know where. Mike Brown, who helped propose the Planet 9 theory, took a look at the data himself. And while he doesn't rule it out entirely, he's skeptical, because the orbit of this candidate object doesn't line up. Planet 9, as predicted, should have an orbit tilted about 15 to 20 degrees from the plane of the solar system. This new object's tilt looks more like 120 degrees. That means it's not just tilted, it's orbiting in the opposite direction from most planets. In Brown's words, that doesn't mean it's not there, but it means it's not Planet 9. But there's another way to explain the strange orbits of Kuiper Belt objects, one that doesn't require Planet 9 at all. Our solar system may have experienced an extraordinarily close encounter with a passing star. Not just one, but two recent studies suggest that a stellar flyby could account for the unusual paths of objects at the fringes of the solar system, as well as some of the odd moons orbiting the giant planets. According to this research, the encounter was shockingly close. A rogue star may have passed within about 110 astronomical units of the Sun, just 110 times the distance between Earth and the Sun. To put that in perspective, that's closer than the Voyager 1 spacecraft, which today is about 164 astronomical units away as it heads into interstellar space. Considering that our nearest stellar neighbor, Proxima Centauri, lies more than 4 light-years away, this would have been an almost unimaginably close pass. To test whether a flyby like this could really reshape the outer solar system, scientists ran more than 3,000 computer simulations. The results didn't just support the idea, they revealed something even more intriguing. The simulations showed that such an encounter could explain two of the most unusual trans-Neptunian objects, both of which have retrograde orbits, meaning they move opposite to the planets. It could also account for Sedna, the distant dwarf planet whose orbit carries it nearly 937 astronomical units from the Sun. According to co-author and astrophysicist Amit Govind, the models point to a star slightly smaller than our Sun, about 0.8 solar masses, passing within less than 4 times the distance between the Sun and Neptune. Even more intriguingly, this event could help explain some of the strangest moons in the solar system. Saturn's moon Phoebe, for example, follows a distant retrograde orbit. Jupiter and Neptune also host collections of irregular moons that may once have been trans-Neptunian objects, displaced and captured by the gravitational chaos of that stellar flyby. This would neatly explain why the outer planets have two very different kinds of moons. Regular moons formed alongside their planets and follow calm, orderly orbits. Irregular moons, on the other hand, have tilted or backward paths and may be outsiders, captured relics from the outer solar system. If a star really did pass this close billions of years ago, it would mark a dramatic and largely overlooked chapter in our solar system's history. So what do you think? Let me know in the comments. Meanwhile, we've already found something undeniably strange at the edge of the solar system. Launched in 2006, NASA's New Horizons spacecraft is one of the fastest ever built, racing through space at more than 36,000 miles per hour. Its main mission was to explore Pluto, a once mysterious icy world more than 3 billion miles from the Sun. In 2015, New Horizons made its historic flyby, revealing a landscape that looked almost alien: towering mountains of ice, vast plains of frozen nitrogen stretching for hundreds of miles, and glaciers that appear to flow like rivers. But New Horizons didn't stop at Pluto. The spacecraft kept going, pushing deeper into the eerie, largely unexplored Kuiper Belt, a vast ring of frozen remnants circling the Sun beyond Neptune. Spanning nearly 2 billion miles, this region is a deep freeze archive of the solar system's birth, packed with icy rocks, dwarf planets, and cometary debris preserved for billions of years. In 2019, New Horizons carried out the most distant flyby ever attempted, speeding past Arakoth, an oddly shaped object that looks like a flattened snowman. This reddish Kuiper Belt object formed when two smaller bodies gently collided and merged, giving scientists a rare, direct look at the raw building blocks from which planets are made. Today, more than 5 billion miles from Earth, New Horizons is still sending data home, its faint radio signals taking over 6 hours to reach us, and its mission is far from finished. The spacecraft continues its journey deeper into the outer solar system and is currently about 60 astronomical units from the Sun. One astronomical unit is roughly 93 million miles, the average distance between Earth and the Sun. And at 60 times that distance, New Horizons has made a surprising and important discovery, revealing something unexpected in the far reaches of the solar system. Because the Kuiper Belt lies so far from the Sun, objects there are barely affected by solar radiation. That means many Kuiper Belt objects have likely remained almost unchanged since the solar system formed about 4.6 billion years ago. In essence, they are time capsules, ancient remnants of the solar nebula, the vast cloud of gas and dust from which the Sun and planets were born. To support New Horizons as it continues its journey at the edge of the solar system, astronomers back on Earth have been closely studying the Kuiper Belt using the Subaru telescope at the National Astronomical Observatory of Japan. So far, Subaru's deep surveys have uncovered 263 new Kuiper Belt objects. But in a surprising twist, a large international team of astronomers, led by Wesley Fraser of the National Research Council of Canada, has identified objects even farther out, pushing beyond what our current models predict. Evidence now points to a hidden structure lurking at the solar system's frontier. Observations show that 11 of these objects lie well beyond where astronomers believed the Kuiper Belt ended, in a region more than 70 astronomical units from the Sun. And that's only the beginning. By analyzing how many of these distant objects were detected, researchers estimated the density of this outer ring. While it's thinner than the inner Kuiper Belt, it's still dense enough to suggest the presence, or formation, of an entirely new structure. Of course, astronomical observations come with limits. Detection biases can sometimes make features appear unusual when they're not. But if these findings are confirmed, they could rule out one long-standing idea, that the solar nebula from which the planets formed was smaller than expected. To get clearer answers, astronomers are continuing to track the orbits of these 11 distant objects. The implications are profound. This is a groundbreaking discovery, revealing something unexpected, new, and exciting in the distant reaches of the solar system, said New Horizons principal investigator Alan Stern of the Southwest Research Institute. This discovery probably would not have been possible without the world-class capabilities of the Subaru Observatory.